4 million miles from home, in the frozen darkness where sunlight is just a memory, a machine is watching. Not watching us. Not watching the stars we know. Watching something else. The James Webb Space Telescope has been staring at a single point in space for 73 days, collecting photons, measuring wavelengths, building an image pixel by pixel, 1 million seconds of exposure time. And what it found there changes the equation. They're calling it Earth 3.0, but that name doesn't come close to describing what we're actually looking at. The signal arrived on a Tuesday morning. Not a radio signal, not a message, just light. Ancient light that left its source 137 years ago, when your great-great-grandparents were children, traveling across the cosmos at 186,000 miles per second, finally arriving at the golden mirrors of humanity's most sophisticated eye. The planet orbits a K-type star in the constellation Cygnus, smaller than our Sun, cooler, but stable in ways that matter. This star doesn't flare, doesn't rage. It's been burning steadily for 8 billion years, twice as long as our own star has existed. The planet itself is almost embarrassingly familiar. 1.1 times Earth's mass, 1.06 times Earth's radius, a 26-hour day, a 381-day year, gravity that would feel just slightly heavier than standing in your living room. But that's not what caught their attention. Dr. Sarah Chen was the first to see it, a spectroscopic anomaly in the atmospheric readings. She ran the analysis 3 times, thinking it was an error. Then she called her supervisor. Within 6 hours, 14 different teams across 4 continents were analyzing the same data. The atmosphere was impossible. 21% oxygen, 73% nitrogen. Trace amounts of methane, carbon dioxide, and something they didn't expect to find anywhere except one planet in the entire known universe. Water, vapor, everywhere, in abundance, forming clouds, creating weather, cycling through precipitation patterns that mirror Earth's hydrological cycle with disturbing precision. But here's the problem with oxygen. Here's what keeps atmospheric scientists awake at night. Oxygen doesn't last. In planetary terms, it's violent, reactive, hungry. It binds to everything: rocks, metals, organic compounds. Left alone, without something constantly replenishing it, free oxygen would vanish from any atmosphere in a geological eye blink. On Earth, that something is life. 3 billion years of photosynthetic organisms, exhaling oxygen as waste, keeping our atmosphere breathable. On Earth 3.0, something is making oxygen. The question is what? The Webb telescope doesn't just take pictures. It takes spectra. It analyzes light, breaking it into components, reading the chemical fingerprints of worlds so distant that their existence was theoretical until the shutter opened. And the spectra from Earth 3.0 told a story that didn't make sense. The first anomaly was the clouds. Not that they existed, but how they distributed themselves. Weather on Earth follows patterns driven by solar heating, planetary rotation, ocean currents. Chaos with structure. Randomness with rules. The clouds on Earth 3.0 follow different rules. There are clearings, vast regions where cloud cover dissipates in geometric formations that persist for weeks at a time. Hexagonal, circular, patterns that would require energy distribution mechanisms that shouldn't exist on a planet without the right geological conditions. The second anomaly was thermal. Infrared imaging revealed temperature variations across the planet's surface that don't match the star's radiation patterns. Hot spots appearing in locations that should be cooler. Cold zones in regions that should be warm. Not random fluctuations. consistent. Repeating. Following cycles that match neither the planet's day-night rotation nor its annual orbit. Heat. Signatures that look almost organized. Then came the methane readings. On Earth, methane comes from two sources: geological processes like volcanoes and tectonic vents, and living organisms, bacteria, wetlands, decomposition. The methane on Earth 3.0 appears in concentrations that spike and fall in patterns that geological activity can't explain. 26-hour cycles, rising, falling, rising, falling, like breathing. But the discovery that made Dr. Chen's hands shake wasn't chemical, it was temporal. The observatory captured something in the radio frequency spectrum. Not a transmission, not a signal anyone designed. Just electromagnetic activity, broad spectrum noise, fluctuating in patterns that contained intervals. Rhythms. Repeating sequences of intensity spikes separated by precise time measurements. Not every 26 hours. Not matching the planet's rotation. Matching something else. Prime numbers. Intervals separated by 2, 3, 5, 7, 11, 13 seconds. Then starting over. Again. And again. Captured over 47 continuous observation periods. Nature doesn't count in primes. Physics doesn't care about mathematics. But something on that world apparently does. The data is classified now. Not because it's dangerous, but because it's incomplete. Premature disclosure leads to premature conclusions, and premature conclusions lead to chaos. But the teams analyzing the findings are asking questions that sound like science fiction. Could this be biology we don't recognize? Photosynthesis that works differently? Organisms that evolved in ways that mirror Earth's evolutionary path but took different routes to the same destination? Convergent evolution on a planetary scale? Or could it be something else? The thermal patterns, the atmospheric composition, the electromagnetic rhythms. Taken individually, each could be explained by exotic natural phenomena, unusual geological activity, atmospheric chemistry we haven't modeled, magnetic field interactions we don't yet understand. But together, they form a picture that looks uncomfortably familiar. Earth's atmosphere is the product of 4 billion years of life, transforming poison into breath. Our oxygen came from cyanobacteria. Our temperature regulation from the carbon cycle maintained by forests, oceans, photosynthetic life, creating a delicate balance. Earth 3.0's atmosphere looks maintained, not emerging, not developing, maintained. The oxygen levels are stable. The methane ratios are consistent. The temperature variations are rhythmic. Everything about this world's chemistry suggests a system in equilibrium, held there by processes that counteract natural decay. On Earth, that process is called a biosphere. On Earth 3.0, they don't know what to call it yet. Some of the researchers are using a different term, a term that sounds absurd until you look at the data long enough that it starts sounding reasonable. Terraforming, not natural evolution, not biological accident. Engineering. The idea is almost too large to hold in your mind. That somewhere in the galaxy, 137 years ago, something was actively maintaining a planetary atmosphere, regulating its chemistry, managing its thermal distribution, broadcasting signals that contained mathematical patterns, doing exactly what humans dream of doing to Mars, to Venus, to the dead worlds in our own solar system. Except they actually did it. Or they're still doing it. Right now. As you listen to these words, that planet is there, orbiting, breathing, existing in a state that our current understanding says shouldn't be stable without intervention. And we're watching, The light we're seeing left that world in 1888. The signals we're detecting are historical records. Whatever generated them might be gone now, extinct, moved on, evolved into something we wouldn't recognize. Or they might still be there, going about their existence, unaware that on a distant world, primates with telescopes are watching their home and asking questions. We've been alone in the universe for the entire history of human awareness. Alone in our thoughts. Alone in our consciousness. Alone in our ability to ask questions about our place in the cosmos. Earth 3.0 suggests we might not be alone in that particular way anymore. Not first contact, not yet, maybe not ever, but evidence. Real, measurable, repeatable evidence that somewhere in the galaxy, chemistry and physics and time conspired to produce the same miracle that produced us, or something helped it along. The James Webb Space Telescope is still watching. Right now, as you go about your day, photons are still arriving. Data is still streaming back to Earth. Scientists are still analyzing, still questioning, still trying to understand what they're looking at. We built a telescope that can see the chemical composition of alien skies, and when we pointed it at the darkness, we found a world that looks back at us across 137 light-years and whispers a single, profound question. What if you're not the first?